Welcome to our continuing discussion on section 4.4. We're actually entering our third day of section 4.4. Here we're going to put everything together with the reference angles and coterminal and evaluate trigonometric functions using the reference angles. So for example, if I wanted to find the sine of 135 degrees, what I would do is I would find the reference angle of theta. So understand that 135 degrees, if I drew the picture, would end up in the second quadrant looking like this. This is 135 degrees. So the reference angle, if this is 180 right here, remember the reference angle is 180 minus 135, which is 45 degrees. So this little angle here is 45 degrees. That's the reference angle. Drawing the right triangle, drawing the altitude, I now have a right triangle. And remember, here's where you have to remember a couple things from geometry. Remember, there's special right triangles, 45, 45, 90. And the ratio, because the sides are the same in a 45, 45, 90, is 1, 1, and the hypotenuse is the square root of 2. Then there's a 30, 60, 90 right triangle. The ratios for the 30, 60, 90 right triangle, remember there's a smaller leg across from the 30, so that's 1. The leg across from the 60 is the square root of 3 times bigger, and the hypotenuse is 2 times bigger. So those are the ratios you have to keep in mind when you're doing these trigonometric functions, because if you notice here, I have a 45, 45, 90 right triangle. So that means I have 1, 1, and square root of 2 for my sides. So finding the sine of this angle here, of the reference angle, remember that's opposite, which is 1, or y over r, so it's 1 over the square root of 2. And remember, you need to rationalize it. So the sine of 100, in this case, the sine of 45 is the square root of 2 over 2. So we found the sine of the reference angle, square root of 2 over 2. Now we have to use the quadrant that it's in. Remember, it's in the second quadrant, and appropriate the right sign. And this is where you have to remember the whole all students take calculus. All are positive in the first, sine positive in the second, tangent in the third, cosine in the fourth. So since it's in the second quadrant and sine is positive, we know that the sine of 135 degrees is going to equal the square root of 2 over 2. It is positive. And that's how you will do it, based upon the reference angle. So let's do a couple more examples. So first, sine 300. So we'll draw the picture to figure out what quadrant it's in. So based upon here, we know it's more than 180, more than 270, so it's in the fourth quadrant. And remember, in the fourth quadrant, to find the reference angle, you go 360 minus 300, so you get 60 degrees. That's our reference angle. Draw the altitude. So now notice you have a 30, 60, 90 right triangle. Remember, the side opposite the 30 is always 1. Opposite the 60 is square root of 3. Hypotenuse is 2. It's wanting you to find the sine, and that's the opposite, or the y value, over the r, so it's the square root of 3 over 2. Now, remembering our all students take calculus, we're in the fourth quadrant, so the only one that's positive is the cosine. So that means the sine is negative, which means our value is negative square root of 3 over 2. tangent 225. So let's draw the picture. .225 is in the third quadrant. And remember, 225 minus 180 is 45. So that means our reference angle is 45, which means, notice we have a 45, 45, 90 right triangle. So it's 1, 1, square root 2. And since tangent is y over x, or opposite over adjacent, notice our y value is 1, our adjacent's 1. So 1 over 1 is 1. Now, in the third quadrant, remember all students take calculus, the tangent is positive in the third, which means the tangent of 225 is positive 1. Now, if they give you the angle in radians, probably the easiest way for some of you to do this, and the way I'm going to show you, is to change from radians to degrees. So 5 pi over 4, remember you times it by 180 over pi, cross cancel, 4 goes into 180 45 times, and 5 times 45 gives you 225. And then you'll follow the process outlined above, which means you figure out what quadrant it's in. And remember, it's the third quadrant. And notice I just did tangent 225 right here. So from there, the process is the same. But if it's in radians, the probably easiest way to change it is degrees, and then go from there, and you know that it's equal to 1, because we just did it. So let's look at a different one. Find the exact value of secant negative pi over 6. So negative pi over 6 in degrees is negative 30. Now, if it's negative, find the positive coterminal. So negative 30 plus 360 is 330 degrees. So that means our angle is 330 degrees. So if I draw the picture, 330 degrees is in the fourth quadrant. So that means there's 30 left over here, because 360 minus 330 is 30. And if I do my right triangle, I have a 30, 60, 90, which means opposite the 30 is 1, opposite the 60 is the square root of 3, and the hypotenuse is 2. Now we're talking secant. Remember, secant's the reciprocal of the cosine, so instead of x over r, it's r over x. So notice our r is 1, and our x is the square root of 3. So basically, if I rationalize it by multiplying by the square root of 3 both sides, notice I get square root of 3 over 3. Now, it's in the fourth quadrant, and remember, in the fourth quadrant, cosine is positive, so that means secant is also going to be positive, which means that this is a positive square root of 3 over 3. Now, if the value is bigger than 2 pi or 360, I would find the coterminal angle, just like I did for negative. So you can either subtract 2 pi or subtract 360 degrees. In this case, I'll just subtract 2 pi. So remember, 2 pi, so 14 pi over 3 minus 6 pi over 3 gives you 8 pi over 3. And notice that's still bigger, so I'm going to have to subtract another 2 pi. So times 3, get a common denominator. So notice when I do, it's 2 pi over 3. So basically, finding the tangent of 14 pi over 3 is the same as the tangent of 2 pi over 3. Which means if I change that to degrees, it's 180 over pi. So 3 goes into 180 60 times, and 60 times 2 is 120 degrees. So basically you're finding the tangent of 120. So we're going to do the next steps. So we rotate into the second quadrant. And remember, 180 minus 120 gives me 60 degrees. So I have a 30, 60, 90. Notice all the triangles that we have done that we can do these trig ratios are 30, 60, 90, or 45, 45, 90. That's going to be the case. So remember, this is a 1 opposite the 30, opposite 60 square root of 3, hypotenuse 2, tangent's y over x, which means it's the square root of 3 over 1, which is the square root of 3. And remember, in the second quadrant, all students take calculus. Second quadrant, the sign is the only one that's positive, so that means the tangent's negative. So our value is negative square root of 3. This concludes our video. Any questions, please feel free to ask me during class. Hope you're enjoying Spirit Week, and I will talk to you later. Have a good day.